Hi, everybody. Welcome. Thank you for joining us in Grayscale's deeper dive into Bittensor. I am fortunate enough to be joined today by co-founder Jake Steves. The point of these, as always, are to make these protocols more tangible for our investors and to help investors understand how they work. So before we jump in, please bear with me. I need to read through a few disclaimers. This call is for informational purposes only and is not intended to be, nor should it be construed as or used as investment, tax, or legal advice, an investment recommendation, an IRA provider recommendation, or an offer to sell or the solicitation of an offer to buy any digital asset or security. Clients of Grayscale may maintain positions in the digital assets discussed on this call, and any opinions expressed throughout this webinar are solely, solely our own and do not necessarily express the views or opinions of Grayscale or any of its affiliated entities. With that, let's dive in. So I'm excited to turn it over to Jake. Can you provide a little bit of background on Bittensor, on yourself? How it came to be and the problem you were originally setting out to solve?
Sure. So I got a degree in mathematics from Simon Fraser University in outside of Vancouver in Canada. And in my final year, I did a lot of artificial intelligence research. I was obviously really fascinated by that way back in 2010 to 2015, back before the deep learning explosion. It was just kind of getting started. Jan LeCun was still a researcher. Geoffrey Hinton was still at University of Toronto. And the thing about artificial intelligence is that it is largely a computational problem. The more that the field has developed over the last 60, 70 years, the more that we've learned that it's about applying a lot of compute, as many flops as you can, and searching a large space to basically speed up the rate of evolution over neural networks. And at that time, I got incredibly fascinated in neuromorphic chips, which were like basically custom built chips, like a TPU, like Google's TPU, or if you've heard of Beth Jezos's startup, Xtropic, like his thermodynamic RAM ideas are all inside this thread of like, how can we actually make the computational substrate of artificial intelligence research faster, right? More like the brain. And I ended up leaving school and working as a subcontractor for a company that was funded by DARPA, building neuromorphic chips. And it was there that I learned about Bitcoin way back then in 2014, 2015. And I got fascinated with Bitcoin. And at this company, we were effectively using electricity to train neural networks. It's a really cool idea. Like, let's just, like the brain, let's put electricity through neurons, and then use that to actually train machine learning models that can maybe go 1,000 times faster, 100,000 times faster than what we can classically do with a von Neumann machine. Like the machine in front of you guys right now is a von Neumann machine. Let's build new computers. Now, at the thermodynamic substrate level, right, where you're just flowing electricity through circuit components, you can easily think of an abstraction for electricity and energy as money. As it's our form, it's our abstracted form of electricity that we use to govern our societies and our economy. And I, way back then, got really into this idea. I guess you could say I saw the light, that potentially we could use humanity's most abstracted form of energy to train machine learning models. And the perfect example of how this could be applied to a computational problem was, at that time, the Bitcoin network, which had grown to be many magnitudes larger than all of Google's data centers combined. I can pause there because I think that's absolutely astonishing, right? How did a non-centralized organization of weirdos across the internet, cyberpunks from basements, build something that a government can't even compete with? And in there is, I guess, the key, like the killer app of doing things that is now called, the field is called DPIN, but back then it didn't exist. And I ended up going to Google and working on enterprise scale machine learning, and all of the ways they do that with parameter servers and large scale compute clusters to train large scale language models. And I got really fascinated with the art, but eventually I was also quite disenfranchised by the organizational structure of a corporation like Google, which I think is part of the ethical argument for what we're building at Bittensor. Um, we wanted to marry the computational power of Bitcoin with the computational problem that is AI, underneath of the auspices or the ethical considerations that we should build this thing in a different way than inside of the classical American corporation style, which has its inefficiencies. And I'll stop there. So that's how it really started, and then ever since 2015, I've been working on it nonstop. And we launched in 2021 with the first network, and I would argue that we invented the space, and now we have a lot of competitors that are trying to do what we're doing.
That's great. And in thinking about, so taking a step back, we've talked a lot, the organizational structure. We've talked a lot, everybody sort of talked a lot about the AI theme and what some dangers might be, the importance of decentralized AI. But I think I'd be remiss if folks listening to this didn't get a chance to hear it from you, because you really put it in an eloquent way that I think people should hear.
Yeah.
No pressure.
Risking sounding a little bit like a hippie. I think that it's important that humanity builds a symbiosis with the machine. And that means connectivity, ownership. It means access and openness. And there is no better technology in the world for doing that than digital currencies, which are the most liquid form of ownership, the most expressive language of ownership that humanity has ever invented. We simply do not have the technology in the legal corporate world to build structures like DAOs, or incentive mechanism based companies where you can get paid based on how much work you do, proof of work, right? So I believe deeply that in order for us to make a safe technology, something is potentially as dangerous. I mean, I'm not exactly a doomer when it comes to AI. I kind of walk a middle road here, but I honestly think that if it is dangerous, it should be something that we can all viscerally own, contribute to, and access. And a lot of companies have different aspects of that, right? Like OpenAI was trying to be open, right? Ultimately, it failed at that because it wasn't open ownership as well as it was open access. Now they're trying to become that, right? They've talked about different governance proposals for OpenAI. They just haven't seen the light that the technology of the standard corporate legal stack isn't there. It just simply does not have the tools or the language to express the kind of things that we need to build in order to make the technology open, owned, and symbiotic with humanity.
And so when you say, digging in a little bit into the idea of something being open, what does it mean? What is the difference, for the benefit of everybody listening? What's the difference between centralized AI, open source AI, and decentralized AI?
Yeah, I would, AI is expensive. Inferencing a machine learning model costs pennies, dollars, and it's not free. So ownership and access it can't just be totally communistically open, right? It's just simply there is not enough compute to inference all those requests. So I think that that's a fool's errand to approach it that way, and that's why OpenAI has had to close. So what is the alternative? And I would say that it's more about openness in terms of your ability to own the substrate, to control how it can be governed, and I think more importantly, transparent. Blockchains have the ability that you can see everything that happens on them, right? And so I think that the openness that we aspire to have is more in terms of transparency and the even playing field for everybody to access this without centralized oversight that might be actually quite negative for some people trying to access the technology. So I think that's the openness I mean when I'm talking about openness in AI.
And so when we talk about the mission, I think that's something that's clear, and the ethos is in line with just more broadly Bitcoin and blockchains. But let's get into Bittensor. What is Bittensor? How does it work? Folks have talked about it being the Ethereum of AI. I think it's important because it's a little bit, once you, even though the mission is clear, I think once you start, it's a little harder to understand for a lot of people.
Yeah.
Network, there's the idea of subnets, there's stakers, there's miners. So, let's just start with how, whatever you can tell us about how high level Bittensor works and, what's a subnet.
Yeah. I want to make a point here is that when we started building Bittensor, the whole idea of decentralized artificial intelligence wasn't actually what we were going for. We actually wanted to build a really powerful machine. Just so happens that it had all these qualities like decentralization. Now, a lot of projects will start with that mission of like, let's make OpenAI, but they don't actually know how to do that. And I think that there needs to be an actual technical innovation, like a raison d'etre that makes sense, like in a capitalistic sense, for that to even sustain itself for its, let's say, altruistic mission. We built Bittensor so that we could build decentralized artificial intelligence networks. We wanted to train large-scale machine learning models across the internet using the computational power of Bitcoin. Now, in order to do that, we started with, okay, well, how can we even validate something like machine intelligence when it is a very, very fuzzy, high-dimensional, probabilistic, statistical thing that very mathy. It's not like a hash in a blockchain sense, or like a block on the Bitcoin blockchain, which is like verifiable, binarily verifiable. It's either true or false. It's either the right hash or it's not. Whereas in the world of machine learning, things are, you just don't know. Like maybe sometimes it's true, sometimes it's not. So we had to start with a consensus mechanism to build a mechanism for reaching consensus amongst the nodes that we were working in this ecosystem, that could work over statistically fuzzy things. And so we invented this consensus algorithm called UMA consensus. And we'd originally pointed it towards incentivizing the production of representational knowledge. That doesn't mean much to people on this call, but basically it's like, hey, let's take a neural network. It's composed of 1 trillion neurons. Let's take one of them. Let's figure out the value of that neuron. Let's incentivize it to perform better and better. We could use representational statistical value or like informational value inside of a neural network. So we built it for this. And then later we discovered that, hey, well, we'd actually built this really, really powerful machine that could build incentive mechanisms for all sorts of different types of things. Because we focused on this really abstract thing, we actually got the rest of the crypto world. We could actually build Bitcoin on Bittensor because it's effectively an incentive mechanism for hashes that secure the network. And so Bittensor has expanded from originally being, if you know your machine learning, what's called a mixtures of experts model, where the miners would produce representations from text, and then those text representations would be combined and joined together, to a whole set of different incentive mechanisms. We call them subnets on Bittensor, and each one of them basically has a collection of nodes, miners, like in the Bitcoin sense, that agree upon the proof of work done by the other miners in the network, and they can be doing all sorts of different things. So I mean, at some point in this presentation, I think I'll have the chance to actually showcase some of those things that they can do, all the way from decentralized prop shops, trading firms, to training machine learning models, and incentivizing the scraping of data, and then bringing that data into the network and basically monetizing it in terms of TAO, the network currency. Let me know if I confused people with that explanation.
No, this is great. This is great. So let's talk about the end applications and how they relate back to the subnets. And then I think that would be a good time for you to kind of show people some of these applications.
Yeah, for sure. So speaking end product, right? So in the world of machine learning, I'm classically a machine learning engineer. The way that you train a machine learning model is you build an objective function, which is basically a way of determining whether or not the AI did a good job or not, and give a numerical value to how well they did. Then you basically perturb the weights of this neural network. You train it so that it can maximize or minimize the objective function. All of the subnets within inside Bittensor have the same form. So effectively, they define an objective, and that objective can be very abstractly defined. And the miners go out and see how they can solve that objective as effectively as they possibly can. So, for instance, give me as much data as you can, and I will pay you more for the speed at which you can get me that data. That builds an incentive landscape where miners come in and try to get the specific type of data that you want them to get, and are rewarded for the rate at which they can acquire it. You encode that into the subnet, and then the miners will do that task. And over time, they'll get better and better and better and better at it. It's kind of like building an abstract machine. It's like you don't build the machine, you just build the way that you would validate the machine. And then the miners go and build the machine for you. In fact, they build a variety of different types of machines that compete to solve that particular problem. Now, the thing that comes out, that data goes to the validators in the subnet, and those validators, they get more of it if they have more TAO. So this is what all of the end products on Bittensor are effectively built on that model. Whether or not it's, hey, we want you to inference machine learning models fast, we want you to train machine learning models fast, we want you to collect data, we want you to predict the stock market, whatever it is, you can build it as we call it an incentive mechanism, an objective landscape, and then you can collect the results by holding TAO within inside of the specific subnets. And if the machine works well, if you can master the art of building good incentive mechanisms, and I can assure you it's not easy. It's much harder than writing a smart contract, and it's somewhere between being a machine learning engineer and a blockchain engineer. If you can do it properly, we can build these incredibly effective, very powerful machines to solve a variety of different problems, all monetizing themselves via TAO, or all accruing value to TAO in the machines in the network.
So let's dive in. Do you want to, if we hand it over to you, do you want to show us? Because I think this is helpful in making some of these end uses tangible.
Sure. Yeah, let's give some. I know there's a bunch of subnets on Bittensor that will be upset that I didn't showcase their things. So if those people are watching, I apologize. I just picked 1, 2, 3, 4, 5, 6, 7 examples. Now there are currently 45 mechanisms on Bittensor, with the number growing basically every week. We limit that just for computational complexity reasons. But I want to showcase maybe the best example would be ones that already have a product. They're taking the digital commodity and giving it directly to consumers. So this is Subnet 19 on Bittensor, and Subnet 19 is an incentive mechanism which rewards miners for being able to inference machine learning models, like large machine learning models. This is a Llama 3, which is an 80 billion parameter model. It requires a stack of H100s to inference. It's very expensive. This is like the major cost of a company like OpenAI. And we framed the problem as an incentive problem. Okay, good. You've got to inference these machine learning models as quickly as you can. So this is an 80 billion parameter model. And I'm going to ask it to, let's say, write me a poem about why dogs are better than cats. I hope I didn't offend anyone in the audience. So what just happened? This front end, which is a product, and they're only able to build this product because they own TAO, took my query and sent it to the miners. And those miners are now streaming these results back to this front end and doing it as fast as they can, because if they can do it faster, they make more money. So there's the poem. I'm not going to read it out. You guys can read it on the screen if you want. But let's look at how this thing is optimizing itself. So this is Namre. This is one of the main devs on this subnet. And this is since June, mid-June, the miners on this subnet have been steadily and incrementally improving their ability to perform this task, which is effectively the tokens per second that they can respond on this Llama 3 billion parameter model. This is like the internals of a subnet. This is the incentive mechanism. This is what the designers look at more than anything, because they're trying to craft their machine to perform better and better over time. The miners are doing this task, and I can talk about a little bit about how they're doing this. It's very sophisticated. And we don't even know who these people are, which is kind of quite interesting, right? They're an amorphous blob of really intelligent people that get to come into a company, and there's no HR department, and they can figure out how they can inference these machine learning models faster and faster and faster over time. Like John Dorbin was one of the miners on this network, that he uses load balanced H100s across multiple data centers to take the request, know where it's going to go back to, and give the request to the correct data center to solve the problem. In fact, he saves money by looking at whether or not the model requires him to actually inference a large model or a small model, and uses the correct machines to do that. So it's very sophisticated, and they're all trying to do this to lower their costs and perform better than other miners. So it's like MEVing in a machine learning sense. That's an example. This is something called Taoshi. It's a decentralized prop shop. I don't know if you guys have ever heard of Numerai. This is an equivalent fork of Numerai on top of Bittensor, where the validation system is a little bit like how hedge funds might reward their traders for performing better or worse with Sharpe ratios, etc., drawdown, daily returns, to see if, and also they can also incentivize things so that they're like decorrelated. For instance, you can get very sophisticated because these validation mechanisms are built, they're just written in Python. So you can write anything you want in the validators to incentivize the miners to do any sort of task. So this is a decentralized prop shop. You can come and you can trade for this firm and do well. There's a number of trading bots that use the outputs of this network, and we incentivize all the miners. Here are the miners. These are trading firms. These are we actually don't know who they are. They could be trading firms, they could be individuals, they could be multiple people. We don't know. But this is an example. This is a Bittensor subnet. This one is incentivizing miners to make predictions on sports games by collecting data and being able to predict well. I'm going to jump on to this one. This is a fork of a company called Character AI. Character AI obviously sold to Google recently for $2 billion, and this network it's got very specific about the benchmark that it wants the miners to perform on. And over the last month or so, they've actually been able to perform better than GPT 3.5 by optimizing the response quality according to EQ benchmark, which is effectively a conversational benchmark. So they can basically take the objective function that is most known in this field and make a company or a subnet on Bittensor focus at this. I wanted to stop here and say that if you look at, say, Devin, I guess if you've heard of Devin, the SWE coder, it's like it was made to write code, and it performed really well on something called the SWE benchmark. They basically took this unknown benchmark and built a $4 billion company around performing better than OpenAI on the ability to write code. So we can do these types of things on Bittensor, and I'll keep on going. This is a folding subnet, speaking to the scientific community and those that are interested in more of like altruistic computation. It's obviously a computational problem to do foldings of proteins. And this subnet in the space of 2 months has built the equivalent of a 440 petaflop computer out of the miners. Would roughly cost $600 million to build if you were going to start out and build this yourself. You don't need to do that on Bittensor. You can just define the objective function that you want to optimize, and the miners will go out and build that data center for you, and you just pay them with the inflation of TAO. And then the last one, this would be the holy grail of artificial intelligence, the ability to train foundation models of sufficient size to be relevant. GPT-4 obviously built on a massive foundation model, and all of the major megalithic corporations in the world competing by buying many thousands of H100s to see if they can minimize the loss in a pre-training objective, which is like the foundational problem in artificial intelligence. So we've been able to structure an objective function to train machine learning models in a decentralized way, which are owned and co-owned by the network. This could be shouted from rooftops because I think it's probably the most significant model ever trained in a decentralized environment. And this was done by a group of shady underground hackers that we don't even know, procuring compute and applying their skills to lower the loss on this specific data set. So these are just 7 of the 45 subnets currently running on Bittensor. You could think of them as individual machines, and these are some of the outputs. So yeah.
And so for the folks listening, can people interact with these? For instance, in advance of this live stream, I asked Corcel what are some questions I should ask Jake Steves? And so, if a layperson like me can use these applications, is it possible that folks out there listening that are curious can do the same?
Absolutely. I mean, I use Bittensor every day because I use an application called Cursor, which is where you write code, and I query the network for prompts, sort of for outputs about how I should write code. And that's actually, it's really fast actually, and it's cheaper than OpenAI for me because I have TAO. And yeah, so like it is usable. Now, I want to caveat that with we're building digital commodities, right? We're building these abstract computational units, and it is difficult to dig them all the way over to the user. Now, people have done that, and Corcel is a good example. Subnet 4, obviously, the fact that I can use it with Cursor is a perfect example of that and how it touches into the real world. But there's a massive iceberg of problems that are being solved every day by companies like OpenAI and Microsoft and Meta, and competing on those problems, which allows them to build these consumer-facing apps that you might not even know about. We're really interested in beating them at the meat and potatoes. We're not. We have great front ends, and those have been built by fantastic designers, but that's not all BitTensor's about. It's about beating these guys at where they know the race is, and the race is there. It's how do you get the best machine learning models? How do you inference them faster? How do you collect the most amount of data? And that's where we think the rubber hits the road.
And so before, because I want to talk about how it works, before we do that, I'm going to ask my favorite question, and it'll probably be your least favorite question. Can we take a big step back, and how would you explain Bittensor to me if I were 5 years old?
I knew this question was coming. You know, I don't have a 5-year-old yet, but I'll get more practice when that time comes.
You have dogs.
I have dogs. They do not understand anything, and I will never be able to explain that to them. Well, when I think about 5-year-olds, I imagine that the type of work that they do is effectively schoolwork, kindergarten schoolwork. And it's a very top-down, hierarchical way of working in an environment which they don't really own, more like a Montessori school, right? I think that as an organization, we've effectively built a corporation that acts like a Montessori school, where you can find where you fit in and what interests you, and you can come and work on that. So instead of being told what to do, you can find out what you're best at and contribute to the decentralization. You can contribute to a grand ideal, a grand project, not just one where you're a mere cog in the machine, but where you have a lot more agency in what you do. So that's what's attractive to the miner community. And I think that's how I would explain to a 5-year-old if I was trying to, recruit him into Bittensor.
I think it would be very effective. I think it would be really effective. Okay, so let's go into, I think this is a good time to talk about how it actually works, because it's a little more complicated than maybe some of the blockchains that we're used to speaking about. Again, we have miners, we have validators, there are subnets. I think there is, if you're ready for it, I think there's a nice little graphic that we can evoke. And maybe you can talk folks through how it actually works.
Sure.
Sort of, in layman. You don't have to speak to a 5-year-old, but maybe to in layman's terms.
Right. Well, hopefully there's some foundational knowledge of blockchains. And so when I say hey, we run on a blockchain, people know that it's a set of validator nodes. And Bittensor, yeah, this is not that great of a graphic, but we could just put it up on the screen anyways. I'll describe it from the ground up. Ethereum is a blockchain which is run by a set of computers that reach consensus in a proof of stake system. They do that by effectively voting with the amount of Ethereum they have. And if they vote incorrectly, they lose money. And that's what keeps them in agreement with each other about what ran on the computer that they're all running. So they all have the same computer. They're updating things. They're running contracts, and those contracts, the outputs of those contracts need to reach consensus so you can have a global state. Bittensor is like Ethereum in the sense that we have a bunch of validator nodes that reach consensus about the state of the blockchain, the transfers, the staking operations. But the actual contracts that run on Bittensor are akin to smart contracts, like in Ethereum, except they're built specifically to build these computational digital commodities. They're smart contracts. The smart contracts are actually the subnets, and they run on the blockchain. Now, the way that these contracts are written, they're written in such a way that there's a whole other network of computers that interact with that contract. So that Bittensor is actually a network of networks. There's the foundational blockchain network, and then there's the networks that use the contracts on the chain to reach consensus about the digital commodities that each of the subnets is producing. So these networks that use the network, gosh, I'm probably confusing people already, but they effectively submit inputs to the chain about how well the miners and the validators are performing on the network, and they get paid in the inflation of tau. So each of these networks are written in a different language, which is called the Bittensor API. It's written in Python, and it's what all the validators of the sub networks run and submit their evaluations of the work done by the miners. They reach consensus. The contract that runs on Bittensor actually forces them to reach consensus about what the miners are doing. So Bittensor from the ground up is effectively a network, and then networks on networks. The miners are also running in these meta networks, and doing work for the validators in the meta networks. And they're doing the work for the validators in the meta networks because the evaluations from the validators is what they need to make money, to make TAO. That's the foundational design of the incentive mechanisms. Now, those miners, for instance, in what's a good example? In the folding subnet, perfect example, they produce folds over proteins that are given to them by the validators, and then they respond to the validators, and the validators check those proteins or a subset of those proteins to see if they're properly done, and then they're rewarded for producing more per second. Those validators are holding TAO. What gives them consensus power within inside of the subnetwork, the ability to determine how much the miners get, is proportional to the amount of TAO they have. So it's a proof of stake mechanism. It's actually a proof of stake mechanism on top of a proof of authority mechanism at the chain level. And the miners will then do more work for the validators in proportion to the amount of TAO they have. So if you hold TAO in the subnets, you get more protein folding, or you get more inferences per second, or you get more access to the trades of the miners, or you get more quickly produced bets on Bittensor, or you get machine learning models that have been trained faster, all framed as a mechanism in TAO on top of our core consensus mechanism, our core network, which runs our core consensus mechanism. That mechanism that makes it so the validators will agree and that the miners will do the work for the validators. That mechanism is called UMA consensus. This is what is like the core innovation of Bittensor. It's the thing that is abstract enough to represent all of these different problems. And so yeah, that's the core technology of Bittensor effectively, and that's how it works. When an inference request comes from that front end, it goes to a validator. The validator takes the request and sends it to a miner. The miner performs the work and sends it back to the validator or directly to the client. And the reason they do that is because if they don't do it, if they perform badly, they'll perform badly within inside of this mechanism, this reward system, this incentive mechanism within inside the subnet. That forces them to do it better. It forces them to do it right. And it's what allows us to access the network, is that forcing. So TAO then becomes the key to the lock, which is the network.
And that's something, the idea of tokens as incentive mechanisms for decentralized blockchains is something I think folks are probably familiar with. What's the supply schedule for TAO? Does it look like Bitcoin? I think it's an important point to just break down for people.
Yeah. I spoke to the founder of Multicoin Capital about this, and he did not like my answer. I said that we have a 21 million cap, and he said, why? And I said, just like Bitcoin. And he seemed to think that was sort of like a not a very smart answer to that question. But honestly, we know that we exist inside of a digital asset commodity landscape. It's an economy, and that economy, like I could say, it dances to the drum of Bitcoin. And so 21 million is our cap. We picked that because it made sense. It's understandable to investors, to people that are holding the token, and it also means that we're closely tied to the what I strongly believe to be the forever winner in the space. So we picked 21 million, and yeah, we're at like 7 or 8 million through the mission landscape.
For what it's worth, I think it's a great answer. Okay, so let's talk about, I know we're going to run out of time here, and I have so many more questions, but let's talk about how you see, so it feels like we're still, if you'd agree with this, we're still early days, right? We're very early days. Where do you see this network growing? What does this look like, I don't know, 1, 3, 5, 10, 50 years from now?
I would say that we're middle. We're like a tween. You know what I mean? We in the last couple of months, people have really begun to understand the art of building incentive mechanisms on Bittensor. It is an art. It's a completely new field. And so it took a little while for that to kick into action. But now we're really beginning to see some amazing results, passing other teams, other centralized teams and benchmarks, training really significant machine learning models. And these kind of things, they haven't really been shouted from rooftops yet. They've been tweeted on Twitter. We don't have a marketing team, but people are starting to look because it really is the fact that we've built something that can be much more efficient long term than any corporation. And I think that in the next couple of years, you'll start to see Bittensor exceeding the pace of many like centralized, highly funded machine learning labs in various problems like data collection, benchmarks of various types, training machine learning models. And then in the next 5 to 10 years, I think it's going to be the one-stop shop for where people come to actually solve these problems in the most efficient way. We imagine that there'll be a number of competitors that try to do it just like us, and we can already see that happening. But Bittensor will always be the Schelling point and the game theoretic equilibrium for the most powerful in these digital commodity systems. So yeah, I think that in 10 to 15 years, 50 years, this is the substrate for a decentralized artificial intelligence company. You could say it more like a nation state, and that rivals and competes, and I think exceeds that of OpenAI in what it does for the world and the products that it produces for laymen and consumers.
And what are the challenges? There's been what are the challenges? What are the shortcomings? What would you worry about in terms of the success of Bittensor?
I think it's always about breaking down permission and seeing how we can align incentives. Like that's it. That's what I focus on. People are always telling me like, hey, you should go to conferences more and stuff like that. I'm like, that's not what's going to move the needle. The crypto projects live or die on whether or not their incentives are aligned. And we have a number of hurdles to go through towards total laissez-faire market capitalism at the miner level, more competition at the subnet level, and decentralization in the governance of the project. Each of those is like a evolutionary step function for Bittensor. And every time that we pass one of these things, it unlocks an exponential amount of new energy into the system. But each of them is really difficult, fraught with error potential, and also legal and compliance risks everywhere. Right? We have surface area still. We're not fully decentralized in a lot of ways. The community is only just beginning to learn the art here. Now, I'm extremely confident, so I don't actually see them as issues. I just see them as like inevitabilities. But I think that each of them will come with their own challenges over the next 5 to 10 years. And if I'm still sitting in the seat in 5 to 10 years and having to be the person that represents Bittensor on every talk show, that's a big problem. So I got to get out of the way as well, and bring up the leaders, of which there are many within inside the ecosystem, to make this thing really move like a nation state that it's meant to be.
So I think we have time for one more question. I'm taking a question that was sent in. What do you think people are not getting about Bittensor and TAO? What's like the most misunderstood thing?
I think that a lot of people within inside of the classical AI world look at Bittensor and go, "That's just a scam. That's just like a crypto scam." And you can't really you can't really argue with prejudice. You simply just have to show them. And I think that people aren't really getting like how profoundly novel the technology is in the AI space. We did merge the fields of crypto and artificial intelligence. At the risk of sounding a little bit, lacking a bit of humility, we are the first team to ever just train a decentralized machine learning model in a sufficient way, in a significant way, and people are just not getting that yet. Like people they just look at, they say that's a crypto scam, and it's like, and eventually that's going to click. So I think that's the thing that people are not getting, that we're actually doing really significant work. We're passing benchmarks. We're applying machine learning to crypto, or crypto to machine learning, and we're really building some novel technology here. So yeah, I think that's the thing that people don't get, and I hope they will, and they will.
Well, we're at time, unfortunately, but this has been really fun. Thank you so much, Jake, for taking the time to chat with me. And thank you, everybody, for joining us today. Have a great rest of your day.